So now that we've talked about our 4 different types of averages, when we are comparing data sets, how do we know which one we want to choose? So let's kind of go through and summarize and talk a little bit about these 4 different averages and when we could possibly want to use them. Our mean is what's most commonly used as average. So for instance, if we were just talking about your average score or your average test score or something along those lines, generally speaking, we're thinking about a mean. Each piece of data is weighed equally. Means can be greatly affected by any change in the data set, including any points that are extraordinarily large or small. So if you're thinking about, for instance, your score, your average on tests, or your average grade in class, if you have one test that is either really, really good or one test that is really, really bad, that can make a big difference on our mean. So our mean is not a good representation of our data if we do have an extraordinarily large or small value. Right, the median is used when we have a few data points that are extraordinarily large or small. So this is the opposite. If we do have one of those values that's extraordinarily large or small, we're going to use our median because it's not as affected by those data points. So it would be a good representation of our data. Our mode is useful if we want to know the most common piece of our data. For example, retailers ordering shirts would want to know the most common shirt size, or builders planning houses are interested in the most common family size. Right? So if we're trying to appeal to a large group, we may want to consider the mode. The mid-range is used when the item being studied is constantly fluctuating, for example, comparing temperatures from different areas. So that would be a case where we would want to use our mid-range. Right, so we're going to go through one example on the next page where we're going to calculate all of these different averages and then do a little bit of comparison using the information listed here. Okay. All right, so the salaries of 10 employees of a small company follow, right? And we see the list of our salaries. Find and compare the averages. All right, so our mean. Right. Remember, we're adding up all of our data values and we're dividing by our sample size. So in our case, right, we are going to add up all of the salaries. And then we are going to divide by 10 because that's how many we have. So I've worked through this ahead of time. If we add up all of these 10 values in this list up here, we get 401,000. And if we divide that by 10, then we get a mean of 40,100. All right, our median. Our median happens if we list these in order from smallest to largest, and then we find what is in the middle. All right, so 28,000, 29,000, 30,000, 30,000, 31,000, 32,000, 33,000, 35,000, 68,000, and 85,000. Right, so we've ranked our data from smallest to largest. We have 10 data values, so we have an even number. So we are going to add our 2 middle values and then divide by 2. So if we add 31,000 plus 32,000, that gives us 63,000 divided by 2. That gives us a median of 31,500. So we ranked our data, and then since we had an even number of data values, we divided by, we took the average of the 2 middle ones. We added them and divided by 2. Right. Our mode is the one that shows up most frequent. And sometimes it's easier if we already have things in a list for the median, we can see if data values are repeated, and we only have 30,000 that's repeated as twice, so that is going to be our mode. Right, the mid-range, remember we take our lowest value plus our highest value and divide it by 2. Right, so again, once we have things ranked using our median, it's really easy to pick out our lowest value and our highest value. So 28,000 plus 85,000 divided by 2. All right, this is going to give us 56,500. All right, now for E, we're asked to list these measures of central tendency from smallest to largest. All right, so we had 40,100 for our mean, 31,500 for our median, 30,000 for our mode, and 56,500 for our mid-range. All right, so smallest to largest, we have 30,000 from our mode. And then we have 31,500 from our median. Then we have 40,100 from our mean. And finally, the largest of these averages, 56,500 for our mid-range. So now, based on these values, if we look back at our data set, again, whether we look back at our original data set or this one in particular, notice that a lot of our values are very similar except for these two large values that are over here on the end. And that's what makes the difference between these different values that we're looking at. Right? So for F, if the employees wanted to demonstrate the need for a raise, would they choose the mean or the median? And explain. Right? So if we compare our mean and our median, from the employee standpoint, if they wanted a raise, then they would argue that their average salary is lower. So the employees would choose the median. Right? They would choose the median because if they were arguing for a raise, it is the lower value. Right? And it is more representative of the data set. Because it is not affected by the two large data values. So they could argue that it's a better representation of the data set because it's not affected by these two values. All right, now, if we look the other way, if management did not want to give the employees a raise, would they choose the mean or the median? Explain. So in this case, if they don't want to give them more money, management would choose the mean. And our mean, right, it's a lot higher. So they would argue they didn't need the raise because they're making more money. And it is a lot higher because it is affected by the two large data values. So there are cases where we would want to choose either the mean or the median based on what we are trying to represent and based on what kind of case we're trying to make or what point of view we are coming from. we may choose our measure of center accordingly.